Okay, guys, I hope that the screen is visible.
Yes, sir.
All right. So, we'll start uh, with trying to read and write some of these very popular file formats. So, other than the plain text file that uh, are probably using, and probably some of you would still be using um, files like these and with different programming languages. One of the things is that Python provides really good library and interfaces for accessing these files, for writing these files. And even though these look pretty simple, these files, it turns out that they have their own quirks and stuff which needs a library to actually handle that. Now if there are no libraries available, then probably you'd end up writing your own functions. But since these are available, and they gave quite a good number of functionalities, so what I'll do is go through these libraries. I'll not try and do it manually, and it's highly recommended that you make use of these libraries for reading these different kinds of structured uh, formats, file formats, or at least semi-structured formats, if not fully structured. Okay, what I'll do is just show you or try to show you if it works. Just give me a second. All right. Hmm. Okay, let me see if this opens. I was hoping that it was open. All right, let me try this again. Okay, so can you see the text file, right? So or are you still seeing the collab one, right? No.
We are seeing the text file.
Okay, excellent. So this is what a CSV file looks like, and this is what a CSV file essentially is. So this is a prototypical CSV file. So you see that this file has several parts. I'm sorry if the font is small. I'll have to just check if I could. Yeah. So this looks much better. I wish that I could give line numbers to this, but probably I cannot. Oh, there is. So, show line numbers. That didn't work. Okay. So anyway, what you'll see if you look at the first line, this is called the header of a CSV file. Generally, it is there just to give you an idea what are the different fields that this file has. So you'll see that it has how many? Five different fields, and each field is separated by a comma. So the first one is a tweet ID, then there's a text, then there's a task one, there's a task two, and then there is another ID. So now what's there in the file is not that important at this point of time, but you'll see that each line of this file will contain actually those five information. So you'll start with this here, the tweet ID, and then you have the text, and then you have what's called task 1, task 2, and then lastly the ID. You'll see that some of these are enclosed in inverted commas. So that's because this text actually contains another comma, and in order to make sure that the computer doesn't get confused between this comma and this comma, and if it fails to understand which one is the delimiter for the different fields and which one is actually part of the text, we actually use the inverted comma around the text to show that that's part of one field, right? So these commas that you use for separating the text, different parts of the file, different fields, so they are called delimiters. And the character that you use for quoting, so self-explanatory, it's called uh, quote characters, right? So this is what you use for quoting and saying that okay, this is part of the same field, and you use a character like comma. So comma is the most commonly used character. The reason is historical why comma is being used, even though, so historically this format was not used for the text files, and the kind of files that it was used for, comma was not generally part of the text in those kind of files, and so comma became most popular. But then you could also use other kind of delimiters, including tab is probably most popular with the text, but you also have semicolons. You could use semicolons as well. uh, Generally nothing else is used, so semicolons very rarely, but commas and tabs are the most popular ones. If there are so given the situation, actually the single space might also be the delimiters in certain cases. This, as I said, this is a very generic format, so you have lots of freedom in deciding how many fields there will be, how many columns, let's say how many columns there will be, and what will be the text delimiters, what will be the code characters, and things like that. Also, it's uh, pretty much human readable, not so I wouldn't say that this is the friendliest of the formats, but it's okay, and it actually works with the Excel sheet as well. And let me see if I have, no, actually closed that. So it you could actually open that with uh, Excel sheet as well, and it will show nicely up as the rows and columns stuff. So that you could use that spreadsheet or Excel to visualize this. um each line in this is one set of information, basically. So it's one row in the file, each line, and uh, each column is one part of that information that you're putting there. Okay, so it's not something which is very technical or very difficult to do or to understand the file format. It's pretty simple. So we'll come to uh, this. Uh, how do we read and you know maybe do something with it and also write uh, the file? So what we'll do is uh, we'll not only read this CSV file. So I'll share this data set that's essentially a hate and offensive speech data set that was recently released for multiple languages, and it's a multilingual document that I showed you. So the CSV file is from that data set, and what we'll try and do is to read and build a simple hate prediction system. Now, it's a very naive, I'm not putting any kind of intelligence in this hate prediction system. The whole idea is to you know to understand how we could read the CSV files and how we could write the CSV files. This hate prediction system is just a small fun stuff that we'll try to do. Not it doesn't involve any machine learning, any kind of sophisticated mathematical stuff there, not even naive Bayes theorem, so nothing. This prediction system, you'll see that is actually too naive to work in any realistic scenario, but this is just for demonstration, and and you will know that where things could be improved at a later period of time. So So one of the things, while I'll share this document just immediately after the class on the Google group. But if you want, and if you think that helps, you could probably try and type out the code part of it along with, while we go into the class. I have written it already. I'm not typing it in the in the class. Generally I prefer doing that. I'm not typing it out because of the time constraints, and it takes little longer to type it out, and we just don't want to make the session really long. So um, that's why it's not actually it's actually pre-written. So the first step, if you are working with Google Colab, is to get your drive ready. That's my preference, my preferred way. There are other ways of getting the files. So if you will open this up, the last one, you will actually see that in the local system, Colab actually provides some sample data. Turns out those are actually CSV and JSON files, the ones that they provide, but they are not actually text files. So they are mostly numerical data that's there. And I mean, if you want, you could explore those as well. Uh, MNIST data is probably one of the most famous data sets out there. So you could actually have a look at that, but I'm not using this. So if you're using one of these data sets, you really don't need to mount your drive. But as you see, my data set is in my Google Drive, and since I'll be sharing that with you, uh, so I need to mount the drive. Also be careful about this when you are doing this. uh, Not exactly in mounting, so nothing to be careful in mounting it. Go to this URL in a browser. You need to go there, click on that. So I'll just demonstrate, if in case there are quite a few accounts in my computer. You might have just one. You choose the account that you want to do. You will have to allow. You are allowing actually your own thing. Once you allow that, you will get this code. So you copy this code. Sorry, you copy this code and come back here, and you enter here. It's called enter your authorization code. You have to enter this, and that will authorize and mount your drive. Okay, so once your drive is mounted, then essentially your drive becomes your local hard disk. Now, of course, there are some couple of libraries that we need to import. CSV is, of course, for CSV. Counter is, if you're not aware, it's just one of those libraries, one of the helper libraries that will help me in counting some of the things, and getting some idea of the data. If you want to know more about your library, about CSV or about any of the other libraries, you could do it right here. You could type a help CSV. So you will get Okay, guys, I hope I'm audible now, right? So can you just confirm?
Yes,
Yes,
you
you
are.
are.
Okay. So the electricity problem continues. I'll share the screen again. Yeah, I hope the screen is visible now. Okay, so as I was saying, you could actually use help in the notebook itself, or you could search the usual way on the Google as well if you want more information about the CSV file, CSV library, not the file. So of course, you could get more information about other libraries as well. Now, uh, this is optional. This is not something that you need to do, right? So this is just to demonstrate that you could actually get help. But so if you run this, you'll see that the whole documentation actually opens up. Sorry, I didn't import this. Import this one. And see that it gives you the full documentation on the uh, on, uh, on this module. So the functions that it uses and that it provides you and everything about this one. Most of the things. So uh, Python documentation is a little uh, it's little esoteric for me actually. But yeah, you get most of the information there, or you could, if you want more information, you could of course search the web. This is the place where you just need to be a little careful because you need to give the path that is there in your drive. So if I am sharing the folder with you, what you actually need to do is to make a copy of that and put somewhere inside your Google Drive. Or if you want, you could download that, and I've shared that collab tutorial where you could actually upload the data from your local system as well. So you could do that, or you could just inside my drive. So till here it's kind of fixed this much. So this is where you will get access to your drive folder. Inside from here onwards, it's whatever is the path inside your drive folder.
Hello, sir.
Yeah. हाँ सिद्धार्थ, आवाज जा रही है मेरी या नहीं जा रही है?
सर आपकी तो आ रही है, सिद्धार्थ ने बोल रहा हूँ।
Repeat importing part.
Shrikant is asking to
सिद्धार्थ तुम्हारा क्लियर नहीं है.
Shrikant is
श्याम,
repeat the mount part. How to
क्या पाथ?
mount the drive.
माउंटिंग
आवाज
द
जा
ड्राइव.
रही है वो
हाँ
श्रीकांत.
हाँ, आ गई आ गई आ गई, ठीक है. ओके. So it's kind of fixed. So mounting जो है ना, this is how you mount the drive. Just
How
two
to
lines of code. You import drive and you just do a drive.mount. When you will run this code,
yes sir.
Sir, your voice is breaking.
I didn't. All right. Let me. Oh, drive is already mounted. Just give me a minute. I'll just. So it will probably improve in a minute. Is it still breaking, or is it better than earlier?
It's clear now.
Okay, thank you. So for mounting the drive, you just need to use these two lines of code inside your collab, right? So you import drive and then you do a drive.mount, and this is also fixed, kind of the thing that you want to. So essentially it's the collab is running on cloud and your drive is also on the same cloud, and this is the path on the cloud. So this is a drive, the virtual drive that Google provides you, which is what you are mounting, right? So this kind of does the trick. When you run it, you will get an authorization link. You click on the link, you will get an authorization code which you paste it, and it's mounted. Okay, so you need to authorize collab to access your Google Drive. The reason being, as I said earlier as well, Drive and Collab are actually not. So Collab is a Google research product, and Drive is a Google product. Now, those of you who have some idea about this stuff, you would know that that's actually not completely meaningless. So Google research is not Google. So that's a separate entity, and that's why you need to provide authorization to collab to access your Google Drive stuff. Okay, even though you are using the same account, even then you have to, in order to mount that, you have to provide authorization. I hope it's clear, right? So how do we mount the Google Drive?
Yeah, I think it's clear now.
Okay. Okay, if it doesn't, so if you face some issues, then we'll come back to this. Now, so it needs to be mounted before you do any of this. So here we are specifying the path of the file from which we are reading. So it's the path to the CSV file. Everything else I have given some extensive comments here just so that you get an idea. It's not there throughout, so because that makes the code look quite cluttered. And so, but in the beginning, I've just given the line by line description of what we are trying to do here. I hope that uh, you would be aware of the other stuff. So I'll just focus on the library part, the CSV part. So you open the file and then you use a CSV dot reader for creating a reader object, and you pass the uh, file object to this function, and optionally a delimiter. So I've just put delimiter. I'm using this parameter here because I just want to demonstrate that you could actually specify the exact delimiter that the file has. By default it takes comma, so if it's comma, then you don't need to uh, you know uh, you really don't need to uh, specify if it's comma. But if it's not comma, then you will need to specify what exactly. So if it's tab or if it's semicolon or something else, then you need to specify the delimiter. And if your CSV file has header, so whenever you are working with these files, you need to have an idea of what kind of file this is. And uh, if it's if it has a header, as our file has one, and if you don't want to read that or store that somewhere, you could actually skip the header using it. So it's a general reader is an iterator, what's called iterator in Python. So it's a general iterator which you could iterate just like any other. So just like any other files are iterators, or you have the list could be iterated upon, strings could be iterated upon. So anything which you could iterate upon. So reader actually creates that iterator, and you could use the next to skip parts of that iterators. The first part is the first line of the file, and you skip that header, so that it doesn't come into your way. If you don't want to skip the header, if you want to use it in meaningful way, you could actually assign it to a variable. So you could simply say header is, or you could name it anything, so it's just a variable. Right? So head is equal to next reader. This basically now has your header inside it. You could store that if you want to use it for while you are writing the file again, or if you want to get some information out of it. So things like how many columns are there, and which column has which kind of information, and if you could process that in some meaningful way. So you could do all of that with this header information. Right now we are not doing any of that, so that's why I was just skipping it. And I that's why I didn't assign it uh, to a variable. But you could do all those things with that. You also don't need to. You could actually when you start looping through it, you could actually start there. Now once you start looping through it, so imagine your CSV file as a table. Okay, the whole file is you could imagine as a table, and that's how CSV library accesses it. So you traverse through each row in the table. So that's what you're doing. You're traversing through each row, and inside each row, each part of the CSV file is actually a column. So you could access that column uh, through its index position. You could also imagine each row as a Python list. So row is actually it's kind of list object, so it's a list object. And just the way you could access each element of the list through your index, in a very similar way you access each part of that row using an index. So basically, if you do row 0, you get the data from the first column, which will be the id in our case, the file that we saw. The second column is row 1, where we get the text, and the third column is row 2, where we get the label. So we only get one label here, and we don't need other information that's there in the file, so we do not store that. We do not use that information. Now so that's the basic fundamental of reading the file. So that's how you get the information out of this. And everything, so all the quirks and stuffs that goes into a csv file. So there are different kinds of characters and delimiters kai jagah pe and things like that. uh, you could actually uh, don't need to worry about that. So it's all neatly presented to you by the csv library as a list. It's already there, so you just use that list. Okay. Now here's the task at hand, and I will not really get into a lot of that, because I'm hoping that you would already understand what's happening. I'll just give you a very, very brief overview of what I'm trying to do and use this data in some meaningful ways. So we are splitting the text into words, and we are adding the labels to a list. And we are also, so this actually I'm not going to use, but just for demonstration, you could actually also create dictionaries and stuff like that. So and I'm creating id label dictionary if you need to use it somewhere. So generally a lot of times we probably need to use that, but in this thing that we are doing here, we won't need to use that. There's just a little bit of logic for appending uh, the labels to this dictionary, label id map dictionary, which essentially has id label mapping, right? So the in the dictionary. Also, if you want to get a little bit of idea about what's the count of the labels, you could use counter. And we could just count that, okay, it has two labels. So hate and offensive speech, which is 6,000, and not offensive is 8,000. That's your data set. Now this is the little naive fun part of this, where we try and predict the predict the level of any sentence that the user inputs to let me run these stuffs one by one, so that we have access to this part. So okay, something is missing. Okay, let me just rename this. Somehow that didn't get saved when I changed that. Yeah, so it's all run and set. Now so we have basically got what we have done is, for each word, for each level, we have got the list of the words. That's a very, very as I said, naive way of doing this. And in fact, it's so naive that if the word is repeated, it's actually entered twice. So I'm not even checking for duplicate entries. So you could do all of that. I didn't want to make this code complex. And
So,
the so what I did was, um,
sorry.
added each and every word uh, of each level. So for, as you'll see in the in the preview that HOF is one level that we have, and it has this whole list of the words that has occurred in with the HOF level in the file, and that's around 97,000 items. Remember that these are not unique words, these are just the tokens that are added there. And the same will be for not. So not will again has a list there, and you have all the words that was there in the not category. Now we simply make use of that. We said that if for any given sentence, you just count how many of those words occur in HOF, how many of those occur in not, and if the count of HOF is greater than not, you label that as HOF, and if not, so that's just a very very uh, naive way of doing things, as I keep repeating. So you could actually enter any sentence. You could tell me a sentence, so I'll say so if you have something like this, let me put right. So and it will give some prediction. It says it's not offensive, right? So using this, if you give something else, something like I'm not sure what this will be. It says it's offensive, so it's not working that bad. So you could give your own sentence. If you want, you could try this out. And so it's basically using a dictionary that was created out of the corpus, and it sees that which of the stuff is more. And you'll see that for longer sentences, it will eventually give not, because there will be a larger number of words that will be in not, and it will not in hof as well. Right, so if you want, we could try out a few sentences here, or not, then you could do it at your own leisure, because you'll have the code. You could try running it with that. Now here are the few exercises that you have to do for this, uh, and they are marked as lab exercise, right? So one exercise is to upload the file directly from the system for reading. You could go back to the collab thing that I shared in the beginning, and use the upload function for uploading the file. Try that out for your lab. That's one thing to try out. The other thing is to make the system uh, in order to make this the prediction system a little bit smarter. You actually modify the code to build a dictionary of count of each word as well. So I'm just at this point, I'm just putting the list of words. You prepare a dictionary with the count of each word, and then you use that count to predict the class. So you basically predict the class based on the count of frequency of the count of frequency, no, so count of each word. So that's really weird. So frequency of each word or count of each word in each class. So you'll basically predict the class which has more words with higher frequency in a specific category in the data set, right? So I hope that's making some sense. I'm not confusing you a lot. And so once you are done with that, so we entered two sentences here, and both the sentences had some prediction. You see that the sentence and the prediction are actually being saved to a dictionary here, right? So we are saving that to a dictionary. That's kind of a log that we are making of what the user is doing. And once uh, so in order to stop this while loop, you just do a simple enter without entering anything, and it quits, it exits so the loop breaks. And then you have that log created here, right? The sentences and the predicted level. You could actually again write that back to a new CSV file. So what I'm doing essentially here is opening a new CSV file, and it's called predicted, and or you could call it log or something like that, whatever name you want to give it, whatever name you prefer to give it. For writing, there is a very handy write row function. So if you want to write one row, so you basically have to pass everything as a list. So you see that this is a list that we are passing inside the right row function. And so this is one row. So you're saying that sentence and its label that will form one row of the CSV file. Everything else, where to put the comma and where to put the quote cards, everything else is taken care of by your library, CSV library. So we have specified that our delimiter is comma. You could probably do something. Let it may be a little adventurous. Let's put it. So it's no adventure at all actually. So we just change the delimiter to /t, and the new file that will be created will have tab as the delimiter, and the file will be created. So that was actually your task for the lab session. So you could change it to semicolon probably for the lab session. Let me change the task. Instead of tab, you could change to semicolon. So you could try changing these delimiters. You could put any kind of delimiter. Also, one thing is, I am just writing the sentence and the label. You could also assign a random ID to each of these sentences and write that as part of your uh, file. Okay, so that's the first part about the reading, writing CSV files. If you have any question in this, please feel free to ask. If you are confused somewhere, if you want me to repeat something, or if you want me to repeat everything, uh, that I will try and repeat everything actually once more. If you're really confused, right? So I hope that the major point that needs to be cleared out is the fact, how do you read a CSV file and how do you write a CSV file. Everything else that happened in between is just a simple demonstration of how one of the ways that this file could be uh, used. So the whole point is to get stuffs from your uh, files on file system into Python data structures, and then again stuffs that are there in Python data structures, you write that back to your file system. So that's the whole point of this exercise. Yeah, are there questions?
So I have a question.
Yeah.
So if we mount our drive, will it be accessible to others or is it completely safe?
No, it's accessible to you. You have mounted it, right?
Okay, no, I'm talking about we will be sharing this particular file with you, right? I mean, as a part of the assignment. So will it be accessible to others as well?
No. So it won't, first of all, so it won't be accessible to others if you're not sharing it with others. If you're sharing it with me, or so whosoever you are sharing it with, the only the file will be accessible. So whosoever wants to run that code, they will actually have to mount it again, right?
Okay,
And so then they'll have to mount their own drive, giving their own authorization. They cannot mount your drive without your authorization,
okay,
right? So
okay,
the
fine.
whole thing will
Thank you.
have to be done, yeah, from the
Okay.
scratch.
Hi, Ritesh.
Yeah, hi, Miraba.
So a very simple thing. Yeah. So you know that I am not in the this group, but yeah, I've just been sitting through. So the thing is that so if I do have some CSV files
Hmm.
in my own system, so how do I upload it to this collab?
So you upload it in your drive, and I'm so that's my preferred way. So there are multiple ways of doing this, but I find it most convenient.
Mhm.
You upload it in your drive, you mount
Mhm.
your drive, and then
Mhm.
you give a path to that drive.
Okay, so okay, our path. That's where I give
Yeah,
the path, and
yeah, that's very good. The path, yes.
okay. Or but there's no other way of directly mounting it without putting it into my drive directly from my system.
Yes, there is. I'll, uh, so I'll just let me see if I could do that. Just give me a second. Probably here. there used to be an over, yeah. So if you look in this, I hope it opens up. Yeah. So just need to go to this overview of collaboratory,
Okay, so it's there.
and yeah, no, just let me. No. So I have actually opened up a galat file. Okay, just give me a second. So let me see. So let me try. So there was a more general thing that I shared. If this doesn't work, then I'll go the other way. Yeah, this is it. So if you see, this is basically the way of uploading. So if you run this in your collab, uh, files.upload,
Okay.
right? So this will upload your file,
Mhm.
and then you read it the usual way,
Okay, and
right?
read it in
So
this.
and yeah, so you could actually upload multiple files. Uh, let me just give. Let me try and run this without the. Let's just see if this works or not. So instead of doing all this business, oh boy, I had to import some of the things as well. Sorry guys about. Yeah, so this needs this. So basically, this whole block is for uploading. One of the good things about collab is that you really don't have to work a lot with this basic stuff, so they're already there. You just use those things, but of course we all need to um, be perfectly sure of what we are using. What happened to the other one that I copied? Did I just lose that?
I believe you kind of deleted it. No.
No, I didn't delete that. It's really funny. So yeah, as I was saying, so one of the good things about this is that a lot of these oh yeah, it's asking me to leave, so yeah, it's probably not saving. So one of the things is that there are these small chunks of code that is already there, uh, uh, that's already there for you to use, at least for basic housekeeping. So of course if there are more advanced stuffs that we want to do, then our own stuff that we want to do, we'll have. Let's hope that this works. Yeah. Okay. So uh,
If this is taking longer, then I think we can do this during the.
yeah,
What you
this
call it?
should ask for a. This should ask you to upload the file, if I'm not wrong. Yeah.
Okay.
So once you run this, it will ask for you browse your file from your local system, and it's there in. Uh, okay, let me. Since it allows you to upload multiple files, there'll be a little bit of bookkeeping that you'll need to do. So let me see. Let me um, I hope that that file is here. Let me open something else. Let me open some CSV file.
Mm.
So now this is your file name, right? This is the original file name that you had, and it will show up here. Yeah, it will show up on your local cache. This is a local cache. So once you log out of a collab, everything that is here is lost. Okay,
Okay.
so nothing gets saved here. So if you don't mount your drive,
Mm.
every file that you create, it will show up here. Every file that you have, you upload, that will also show up here. And if you want to save some of the files that you have generated, then you will need to go here and download that before closing collab. Okay,
All
because
right.
otherwise that file is lost. So you could actually upload and download, and you could use it. So this could be used directly without uh, doing your uh, mounting your drive.
Okay. So the files that are there in the system, yeah, which I can access, can be used directly.
Yes, uh, from here. Yeah.
Mm.
So you'll have to do this upload first. Once you have uploaded, it could be used directly.
Okay. Yeah, I'll try this. Yeah. Thank you.
Yeah, and if at all you don't want to use collab, that's also fine. You could use the same code.
Mhm.
The same code will work on the local system as well.
Okay. No,
If
because
you're
because a lot of most of my files are basically Prat generated CSVs, right?
hmm,
Prat and R generated CSV files. Most of the experiments that happens in phonetics and phonology,
yeah.
the derivative that you will get them from either from R or from Prat scripts is basically CSV files in on the system already, right? So do I need to actually upload them again on Drive? That's the question.
No, not at all. So you just use this bit of code on your local system. You install Python on your local system, and just run this code with the usual things. So we'll talk more about how to traverse through the through the directory and access multiple files in the basic track. And so you could do it on your local system. It doesn't have to be uploaded here, not at all. So this is if you want to work on collab, then this is the way. Otherwise local systems are just fine.
Yeah. Right. Thanks.
Okay, are there other questions?
Sir, could you please repeat the lab assignments? What are they?
Okay.
Hello.
Yeah, I got that, Sham. So lab assignments are written as lab exercises. Now I'll just go through these again. So the first one is of course the one that I just did. So yeah, and I'll remove that part of code so that you search for that and do it yourself. So you upload the file directly from the system for reading instead of doing it from drive. So you try this drive thing out, and then you also do it directly from the system for reading. Okay, that's the first assignment. And let me see. Now the second assignment is to here we are creating a simple list of words for each label. So we have two labels, HOF and not. For each of these categories, we are creating just a list of words which we are using later for predicting the hate speech category. But your task is to build a uh, dictionary of the count of each word, right? So not just the list of words, but along with that, you also need to make a dictionary with the count of each of those words. Okay. And the third assignment is actually to use that count for predicting the category of a new sentence, the way we were doing here. So instead of just looking for the number of words that are occurred in each of those categories, you also look for you basically look for how many times that specific word has occurred in each category. And the greater so say some word, there is a word like is, which occurs in HOF and which occurs in not. So if you look at the frequency of is in HOF and in not, and if you see that the frequency of is greater in HOF, then you will count that as an HOF word. Okay, and the final logic is same, that if you have 5 word sentence and 3 words occur more frequently in HOF, then then it's HOF. If uh, uh, if 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 it's a 10 word sentence and there are 6 words that occur more frequently in HOF, then again it's HOF. But if there are 7 words that occur more frequently in not, then it's not. So that's essentially the simple logic that you'll be using for predicting, right? So that's the third part of the task.
Hello.
Yeah.
Sorry, I just want to know, like, when we can get this file, like what you are showing in the
Right now,
screen.
so just after the class, as soon as it finishes, I'll share it in the link to the drive. So this file as well as the data sets that are there, so I'll share the whole folder with you on the group, on the
Okay,
intermediate
thank
group.
you.
All right,
Hello.
so yeah.
Hello. Is that unique words in the last assignment?
Yes, it will have to be unique then, because you're counting frequency of each word. So that, I mean, that will make it unique, right? So you cannot have 2 frequencies for the same word, right?
Okay, okay. Yeah.
So you're counting each and every word. You could use counter actually for counting the words. So, if you'll think about it, it's not really that difficult a task. You already have a list of the words. You just put a counter on that list and you get the frequency of each word, right? So that's pretty much how you count the frequency, and then you do a little bit of change here and you will get the. So these are not really difficult changes that you'll make given the. I mean, so given the fact that Python gives you some really good helper functions, right? So you using the counter and using stuff like that. Uh, so otherwise, if you'll do it manually, counting the frequency, that will take a bit of a time. Using counter is just one line, right? Okay, so I guess if there are no more questions, I'll just very quickly go through the JSON thing. And there is actually a JSON dataset as well. Essentially the task is same, so it's already peeping through my screen. So we are doing exactly the same thing. You'll import JSON and you will import counter and stuff. So that's already imported actually in the sheets. That's why I didn't import it again. You provide the path, and the only difference in this code that exists is because of the different file format, and also the file is of a different kind, right? So for reading JSON, there is a library called JSON, and it gives you a couple of helper functions again. So there is a load s, and which basically uh, so I forgot the exact term that they use. So it's something like it encodes the string into a JSON object, right? So, and there is also a load function which directly reads from a file stream. So basically the kind of JSON that we are using, it has, if you take a look at it, I'll try and show you that JSON file. Yeah, this is one. So let me make this a little bigger. Yeah, if you see that, it's basically a collection of multiple JSON objects. So it's not really one JSON file. So it's essentially multiple JSON files, each on a single line. So in order to read files like this, we get each line into a string and then use a load s. However, if you have a file which has just one JSON object inside of that, and so you could actually make this one JSON object, you could put another brace here and then another one at the end of the line, and that will be your uh, and then you'll also have to put a bracket, a big bracket stuff. So not the brace, you'll have to put a big bracket here and at the end, and that will make it a single JSON file. So and then you could directly use load, but I just wanted to demonstrate because these are the kinds of files that are actually more, I find these more popular in lots of places. So uh, you could do it both way. You could actually read it the whole thing as a string and then use load s to encode that as a JSON object, or you could use load for reading it directly uh, from the file object. So once that's done, so once you do this json.load s and you pass the string to this, uh, uh, the whole JSON object is actually now stored in this variable called, for some reason it's called pj, and so um, you could now actually access the file as Python list and dictionaries. So what you will essentially have here is this will be converted to a Python dictionary. It looks a lot, I mean, it looks exactly similar, exactly like a Python dictionary. So you have this key and this value, you have this key and this value. So these, you have these different keys and values here, right? So this is exactly, or what you call maps in the general programming language. So what the library does is basically convert this thing which looks like the string representation of a Python dictionary into Python dictionary, and then it becomes easy. So whatever information you want out of this, you could actually use that key, and you could get the value for that. So we'll get the value for the same stuffs, the ID, the sentence, and the label, right? So these are the three things that we got for the last data set. See, the two data sets are very different structure, so their arrangement is different, pretty different, but they have actually very similar kind of information. This one is an event detection dataset. So it's actually a dataset that was created for uh, recognizing whether the so it's a news data set, and it in every sentence it's supposed to recognize if uh, that sentence contains some kind of event, or so more specifically some kind of protest event or not. So will the protest event data set, and 0 means that the sentence doesn't mention any protest event, and 1 will mean that the sentence mentions a protest event. The task is of course to recognize whether a specific sentence is representing protest event or not. And as usual, we will not do it very how do I put it, very mm, in a very sophisticated manner, but in a very naive manner we'll do it. So essentially we are taking out the sentence, ID, and label. Just those are the keys of your data set. You get that sentence, ID, and label, and you do exactly same thing. So now you have all those three information that we had in the from the CSV file. So ID, text, and label. So you have that ID, text, label here as well. You do exactly the same processing, right? So you strip. So also for ID, there is a little bit of thing that we are doing here, because you'll see that um, well, no, not exactly. So you could directly use the ID in this case. So I was assuming that if it has sentence number and ID both, then ID will be common across things, but it turns out that it's not. ID is actually unique for each of these, so you could directly use without doing that extra bit of processing that I'm doing. So you could actually directly use. Yeah, let me just put this out of the picture so that it doesn't. Also, you need to convert this into a string if you want. If you don't want, that's also fine. I am converting into a string the ID, because ID is number, and the library reads it as a number. Uh, so the data type assigned to is an integer. But if you want, you could convert that to a string. So those are the little stuffs that you just need to make it work. Otherwise, everything is exactly same. You have then you I'm doing the exactly same thing, and the modifications that you have to do is actually it has become to the perils of copy paste. So the exercise that you have to do is exactly same. We have read the data from the JSON file and brought it into exactly the same kind of structures that we did with the CSV files. And then we are processing it in exactly the same way, even though the task at the minute level is different. So one is the hate speech detection, the other is protest event detection. Essentially, at a larger level, both are what's called the classification task. So you're trying to classify things into certain kinds of categories. So the same kind of changes have to be made here. In fact, if you do the CSV ones, you will not need to do this on one. You will actually just have to copy and paste the same stuff here. So for the for this assignment, and at the end you'll see that instead of writing back to the uh, to a CSV file, we are actually writing back the information, the log information, to a JSON file, just to demonstrate how you write a JSON file. So you use the dump function. If you have used pickle in Python, if not, then don't worry about that. But if you have used, it's very similar to pickle. So it dumps everything there formatted as a JSON file. Now, if you want to use the JSON thing as JSON formatted string, then you could use dump s as well. That will generate a string for you, which you could use later in the program as well. So you have these 4 sets of functions for reading and writing JSON files. So load and load s. Load is for reading from the streams, mainly from the file stream. Load s is for encoding the string into a JSON object. uh, Dump is for writing to a file stream basically, and dump s is for writing the JSON object to, so basically getting a string, a representation of the JSON object, right? So those are 4 things. Everything else we are doing exactly same. The whole idea of this is to show, to demonstrate that irrespective of what different kinds of files you get for different data sets, they most of the times they contain very similar kind of information. So ID, the text, and the label, that's actually common. That's bare minimum that you'd expect in any data set that is meant for text classification, right? Also that is meant for so that you will use for other tasks. So tasks such as, even if you're doing corpus based analysis, you may or may not have labels. If you don't have labels, then you work with the raw text, but if there are labels, they are helpful. So you get those labels and you get all of those text and IDs. You could actually bring everything into a uniform data structure in Python. So the main job is to think of the problem in such a way that you could bring it in a data structure that you could process later. And once you get that in that similar data structure, you could do a lot of tasks in a similar way. And this is nothing, whatever I'm saying is not actually a, it's not, these are not words of wisdom. This is what we could really call common knowledge. uh, so and that's the whole point. So it doesn't, it's not, so if you encounter these different file formats, don't get afraid of those. You could actually use these libraries to bring it in Python data structure that's familiar to you, and that's you could use for whatever purpose you want to use it. And of course, then you could also use the same libraries for writing it back in any format that you want to write. I've not used functions in this, but you could actually convert all of these into function, and instead of doing all of this, so you could just call the function to get a uh, instead, so this could be put in a function. The logic, it was not large, so I didn't put in a separate function, but you could put that in a separate function. You could call that function for prediction and things like that. So you could so what I'm trying to say is that this code could be made even better. This is probably not the best written code, but again, the idea is just for to demonstrate how CSV and JSON libraries work in Python. Okay, so that's it about so this is not really a lot of things that we covered, but that's it for from my side for this session, and we'll meet at around 3:15, 3:30 in the lab session. I hope you'd be able to finish this the the lab session work in relatively short period of time, right? So if there are questions, I'll be happy to answer.
So,
Yeah.
so if both JSON and CSV are structured data, then
Hmm.
how will we? I mean, how will you decide that for which task which is convenient? I mean, why you will use JSON for certain kind of task and why will you use CSV for certain kind of task?
It's up to you. I mean, whatever you like more. So one, yeah, there is one difference though. So if your data has if you need to transfer it over the web, over through a server, generally we use JSON. CSV kind of doesn't really work well with the browsers, so it needs a different
Okay.
software to open it up. So that's one situation where JSON is preferred, it's recommended. Other than that, it's actually up to you. So a lot of people, if the server and this stuff is not involved, they prefer CSV, to work with CSV,
Okay.
right? So it's like saying, so it's a decision. It might be a bad example, but so you have a kurta to wear and a shirt to wear. How do you decide which one to wear when? I mean,
So it depends on the occasion, actually, sometimes.
yeah, but it's not decided, right? So I could decide to wear a suit on my marriage. Somebody could decide to wear a sherwani or a kurta on their marriage. So it's personal
Hmm.
choice, right? So it's almost like that.
Okay.
It's your
Okay.
choice.
Actually, I thought there can be certain limitations because of which you can use JSON in certain tasks and you cannot use JSON in other tasks. I thought something like that.
No, these are very generic file formats. So you could represent very different kinds of stuffs in JSON and CSV. So and also XML. So one of the things is that JSON is also a hierarchical format, which CSV is not per se. So CSV is more of a flat representation format, so you cannot show the relationship between those different things out there explicitly. So you just have a row and you have these all these different things dumped together, separated by a delimiter. In JSON it's more informative, so you are actually saying which one is which. You could also see that this one is under the other one. So actually we do this thing in CSV as well, so but it's not that clear in the format itself. So when we have, so you saw that hate speech data set, uh, that actually in there we have a hierarchical data. So task 2 is there only when task 1 is HOF. So the moment task 1 becomes not, task 2 is not supposed to be there. So there is a hierarchy, but that hierarchy is not apparent in the formatting of the file. But people find it more convenient to work with CSVs, most of the people, so they do it in CSV. This could probably have been better represented in a JSON file. So if you have hierarchical information or nested information, things like that, then JSON or an XML could represent that information in a more clear way, in a more explicit way than CSV. Right. So uh, but then there is no strict condition on what you should use or you could use. So as I said, so it's your it's a matter of personal choice most of the times. What do we choose, right? So but there could be
Okay.
recommendations based on what kind of data you have and which one you want to use.
Okay. Okay. Thank you, sir.
Yeah, okay. Okay, I guess then I'll stop sharing this, and if there are no more questions, then we'll meet in an hour from now. Yeah, so mm, yeah, I guess so. There are no more questions, so I'll end this session now, and we'll meet in an hour from about an hour from now in the lab session. Hopefully, you'll be able to finish this task. Thank you very much.